Good afternoon, everybody. I'm Tilak Bhusal from WVU Pollution Prevention Lab. In this presentation, I'll walk you through how modern tools and techniques in building energy management can cut energy use, reduce utility cost, and support sustainability without sacrificing comfort. My goal is to make the topic simple, practical, and actionable for everyone, regardless of the background. So here's our roadmap for today. We'll start with brief introduction and the global context when the outline the building energy management approach, the tools and the techniques available, and the main focus areas where savings are found. We'll look at the real case studies, thoughts on economic impacts and ROI, and end with key takeaways. So let's start with the introduction. So buildings, they keep us safe, comfortable, and productive, but energy is the hidden engine behind all that. Rising energy prices and climate goals means we can't treat energy as an afterthought anymore. Smarter management helps us get the same or better outcomes, comfort, reliability, and safety while using less energy and money. So globally, buildings are among the largest energy users and emitters, which means even modest improvements make a big difference. Both homes and commercial buildings contribute to this footprint, and both can benefit from better management. If we want healthier indoor environments and lower bills, this is one of the most effective places to focus. Buildings use a big share of electricity, and heating and cooling often dominate overall demand. In many regions, cooling demand is growing quickly as temperatures rise and cities grow. The takeaway is simple. Energy management is not optional. It is a strategic part of the operating any building responsibly and affordably. So what is building energy management system? A BEMS combines sensors, controls, and softwares to continuously monitor and optimize how a building uses energy. Instead of a one-time tune-up, it's a living system that finds waste, maintains comfort, and adapts to changing conditions. Think of it as your building's energy autopilot with you in command. So there are the two approaches for building energy management systems. So traditionally, many facilities run reactively, fixing problems when complaints or failures occur. A modern approach is proactive and data-driven. We anticipate loads and weather, track performance in real time, and adjust system before waste or discomfort occurs. So the result is fewer surprises and steadier comfort and lower costs. So what is ISO 50001? So it gives a simple improvement loop: plan, do, check, and improve. So it turns scattered projects into repeatable process with goals, measurements, and accountability. Even if you don't certify, adopting the mindset helps teams maintain savings year after year. So with basic measures and good controls, many buildings see 15 to 30% energy cost reduction plus better occupant comfort. Because equipment runs closer to its sweet spot, it lasts longer and needs fewer emergency repairs. The result is a building that's easier to operate and more affordable to own. So now we dive into tools and techniques that are used in building energy management system. And the first one is model predictive control, also known as MPC. So MPC looks ahead at weather and occupancy and selects the best control action for HVAC and lighting and other building facilities. Compared to fixed rules, MPC typically holds comfort more steadily and trims energy use by optimizing and when and how equipment runs. It's like cruise control that anticipates the hill rather than reacting late. So the next one is white box modeling. White box models use physics, real-time physics, to simulate the building in detail with its envelopes, zones, and HVAC components. They're excellent for design and retrofit planning because you can test scenarios safely on the computer first. They require more inputs and expertise, but pay off when you are making big and long-term decisions. So you can use Energy Plus to do white box modeling. So you can think of this as a physics-based digital twin. Change a window spec, add insulation, or tweak an air system and instantly see how that affects energy and comfort. This helps teams choose measures with the best performance and payback before spending $1 on hardware. So the next one is gray box modeling. Gray box models blend simplified physics with your measured data. They run faster and need fewer details, which is great for demand response or near real-time control. You get credible predictions and smoother operations without the heavy lift of a full physics model like a black box modeling. So the next one is black box model. Black box models use machine learning to find patterns, excellent for short-term load forecasting, anomaly detection, and fault finding. They're fast and powerful, but they need good data and can be less transparent. So when we often pair them with engineering judgment or simpler checks. So the last tool and technique used in building energy management system is big data and IoT analysis. So modern BEM pulls in smart meter data, weather feeds, schedules, and even utility rates. With that information, we move from what happened to what should we do next. Analytics can highlight stock dampers, misset schedules, or drifting set points, small issues that quickly burn money in building. So the next are the focus areas. So the first one is HVAC. The heating and ventilation and air conditioning uses the highest portion of energy used in building. So it's the first place to look for savings. So common wins include adding variable speed drives, using demand control ventilation to match fresh air to real occupancy, and doing predictive maintenance to fix faults before they become crisis. So these steps save energy and improve comfort. The next one is lighting. So lighting is the low-hanging fruit in energy efficiency industry. So LED retrofits combined with occupancy and daylight sensors can cut lighting energy dramatically, often up to around 60%. Beyond savings, better lighting design improves visibility, safety, and satisfaction. It's often a quick project with short payback. So the next one is building envelope. Insulation, air sealing, and better windows reduce heating and cooling losses that otherwise leak your budget to the outdoors. Roofs, walls, and infiltration are common culprits, and sealing or insulation them often pays back quickly. The envelope sets the foundation for all other measures to work better. So the water heating and domestic hot water. Service hot water can be top 3 end use in facilities like hotels, hospitals, and gyms. Heat pumps, water heater, heat recovery, and smarter recirculation controls reduce waste while keeping hygiene and safety intact. When scheduled with off-peak prices, DSW can even help lower demand charges. Renewable integration. So on-site solar and battery shine when paired with flexible loads, pre-cooling a building, charging a hot water tank, or shifting EV charging. Coordinating these elements reduce bills, support the grid, and improves resilience. It's not just generating energy, it's using it wisely. So let's dive into the case study that our lab has done in the state of West Virginia. So in one facility in Wheaton, West Virginia, so we replaced hundreds of older fixtures with LEDs that cut electricity use substantially and paid back in under a year. So the lesson is start with obvious and repeatable measures first. Lighting is often the lowest risk win and builds momentum for deeper retrofits. The next one is HVAC case study. So right sizing and modernizing HVAC equipment reduce annual electricity use while improving comfort. When equipment matches the actual load and controls are tuned, systems run fewer hours at better efficiency, saving both energy and maintenance. building envelope. So adding efficient or energy efficient insulation with high R value and addressing thermal breezes, improved indoor comfort and reduced energy use. Envelopes works doesn't just save kilowatt hours, it stabilizes temperatures and reduces drafts, which occupants notice immediately. Although the payback period is higher, but we're compromising it with a better working conditions for the employees. So installing variable frequency drives on compressors and fans got energy use with a solid payback because power scales with speed. Even a small reduction in fan or pump speed can produce large savings while maintaining performance. Let's talk about the economic impacts of the building energy management system. The market for building energy management solution is growing quickly as organizations seek cost savings and carbon reductions. Typically, projects show ROIs of about 2 to 5 years with 15 to 30% energy savings and lower operations and maintenance costs. These upgrades also support environmental, social, and governance goals and green certifications for your building. So buildings have large footprints, but also a large opportunity to save energy. By combining good design, continuous monitoring, and smart controls, we can deliver comfort and reliability while spending less. The technologies are ready and the economics are favorable, and the best time to start is now. So thank you for your attention and engagement. So our aim is to help facilities save energy, money, and emissions in ways that are safe and practical. So I'm happy to take your questions and hear what challenges you're facing on the ground. And so your feedback helps us improve and share what works more widely. Please scan the QR code to tell us what was helpful and what you'd like to see next. Thank you.